Finally, the North Pacific to turn active. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, February 1st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below. With that, I'd like to thank the folks that donated last week. Clay Goose, E. Slate, B. Nadine, Coach Nate, and Matt and Ella McQuirk. Thank you all so much. I really appreciate it. With that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, we have a small gale with 23 foot and 24, maybe 25 foot seas circulating here over the dateline. We also see a little bit of energy, 18 foot seas pushing into the Pacific Northwest from a previous gale, and you see a swell front starting to impact Northern California, but nothing particularly huge. In the South Pacific, there's a gale with 22 foot seas, not doing anything of interest, but believe it or not, there's actually something behind it that might be of a bit more interest to us. In the North Atlantic, probably the largest gale, 26-foot seas here, targeting Portugal down into northern Africa, and another gale winding up off the mid-Atlantic coast with seas approaching 30 feet. In the South Atlantic, things are pretty quiet, and in the Indian Ocean, pretty quiet pattern as well, maybe some 17-foot seas, but nothing of any particular interest. But before we get into all that, let's take a look at current conditions. We're going to look at the buoys. Starting up in the Pacific Northwest, the Grays Harbor buoy here, number 036, off the intersection of the Oregon and Washington border. We're looking at all the energy that's hitting that buoy, all the way up from 33.3 second period energy. There is 1/10 of a foot impacting the buoy there, all the way down to 5 second period, just pure wind chop, unrideable surf. We're looking for peaks. We see one here at 9.1 seconds, another little bit in the 11.8 second period range, and probably of the most interest, swell at 15.4 seconds. The swell is not limited to this one frequency, though. You got to consider the energy on the shoulder in either direction. We use an algorithm to pull that up. Sure enough, it says primary swell is 6.2 feet at 10.2 seconds. That's the largest swell from 239 degrees, making surf at 6.3 feet. That's about a foot overhead at your standard beach break, bigger at areas with swell-enhancing bathymetry. Then secondary swell, 4.6 feet at 13.3 seconds from 261 degrees, also putting surf at about 1 foot overhead. For those of you in Northern California, we are pleased to announce that the Point Reyes buoy is back. Buoy number 029, right off the tip of Point Reyes there. Looking at the energy, we see a defined peak of swell in the 14 to 15 second period range. Nothing huge, each frequency at about 3.0 feet with wind swell over on the lower end of things there. Primary swell, 5.8 feet, 14.7 seconds from 265 degrees, making surf at 8.5 feet, and that's about what it looked like when I looked a few minutes ago. And secondary swell in the mix, 4.6 feet at 11.3 seconds from 269 degrees, adding another 5 feet of lesser period energy into the mix. Down to Southern California, the Point Loma South buoy, number 191. We see a defined peak of energy here between 15 and 16 seconds, and then a bunch of wind swell below that. Let's see how the algorithm does. Here we go, 2.3 feet at 15.8 seconds from 284 degrees, making surf 3.7 feet, with secondary swell 1.8 feet at 12.4 seconds from 272 degrees, or adding another 2.2 feet. They do not add together, they just interact with one another. Yeah, there were waves. I saw some surf in the shoulder high range sort of thing when I looked earlier this morning. over to the north shore of Oahu, and there is swell there as well. We're looking at the Waimea Bay buoy, number 106. Now, this swell is fading, but there is much more bound in behind that, and that same swell that's targeting the Hawaiian Islands will also be targeting the U.S. West Coast and coming from a much more westerly direction than anything we've seen so far this winter. Anyway, looking right now, we see the most energy in the 12 to 13 second period range, 2.9 feet at both those frequency bands. Primary swell, 3.9 feet at 12.5 seconds from 316 degrees, making surf 4.9 foot. And for Hawaii, given all the reefs and everything, that's 4.9 foot Hawaiian. And then secondary swell, 3.2 feet at 9.5 seconds from 329 degrees with a little bit, so secondary swell at 3.1 foot. So let's go take a look and see what's been going on over the past week. We're going to start in the North Pacific on Sunday. A week ago, last week's video, there was a little area of seas with 24.3 feet. These are the highest seas over this entire domain. Right there where the little plus sign is, plus, and you see an X over top of that too. That's the highest winds where they're located, 42.2 knots. So a little bit of a gale there in the northern Gulf. It built with 28 to 30 foot seas into Monday, the 26th of January, falling southeast. A little bit of swell pushed into the U.S. West Coast. I think it was there on Tuesday. Another gale built off the Kurill Islands with 30-foot seas, 28-foot, not a whole lot. You know, you get the idea. Swell pushed into the Hawaiian Islands on Friday, and then off the U.S. West Coast on Saturday into Sunday. That is the swell that is hitting Northern California now as we speak. You can see the swell front right there as of 12Z. We got to the 18Z run. And another little gale trying to fire up over the north date or over the date line there, but nothing too particularly interesting yet. Again, there is more behind that. Then looking over the past week in the South Pacific, not a whole lot happened. Notice the ice line well recessed compared to where it was last July and August sort of thing. See a little bit of energy trying to push under New Zealand. This was on Friday the 30th of January. Built a little bit, seas to 27 feet over a tiny area, but not nearly as impactful as what we believe is coming behind that. Over to the North Atlantic a week ago, 29 or 28 foot seas, 28.9 feet. Seas developed off of Newfoundland on Sunday, the 25th of January. Built with an area of 43 foot seas, pushing towards mainly Portugal, a little bit towards Ireland. That hit on Wednesday. Another gale developed behind that late Wednesday into Thursday, the 29th of January, with 40-foot seas aimed off to the east. That moved into the Bay of Biscay on Friday, was fading. On Saturday, just a day or so ago, another area of 39-foot seas developed south of Greenland, not Iceland, and was lifting northeast and faded. And here we are as of current time. New gale winding up off the European coast. New gale building off of the mid-Atlantic. Reviewing the past week in the South Atlantic, we'll just put this into motion. I don't believe a whole lot happened, a pretty quiet pattern. There we go. We did have one little area, 28-foot seas late Wednesday into Thursday. That pushed south of South Africa with seas down to about 26 feet, but you see a swell front pushing towards South Africa and impacted it early on Sunday. That'd be a 12Z Sunday, so that was noontime today. And then here is current time. And then finally, over to the Indian Ocean a week ago, we see a swell front that was impacting Western Australia and pushing up into Indonesia on Tuesday. Beyond that, we roll it out. Quiet pattern, a little bit of a gale with 33-foot seas tracked east over the deep South Indian Ocean. Not really did a whole lot, and there we are. You see some swell from that trying to push up into Western Australia as of Sunday. Now let's do a deep dive into the North Pacific forecast. We're going to start by looking up at the Jetstream. This is a chart of Jetstream level winds. These winds are up about 30,000 feet. They help support the formation of gales when those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south, and you just barely see it sort of right there. Upper level low pressure system at 9,800, I think that's meters. But what is striking is the jet stream is pushing consolidated, all holding together off of at about the 35 north latitude off of Japan with winds to 200 knots. That's pretty strong indeed. Feeding that trough. That trough, because it digs out that way, creates a counterclockwise eddy in the upper atmosphere and also down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, generating seas. Those seas, as they radiate away from the fetch area, the lesser period elements decay away, exposing longer period swell. And that swell, when it pushes into your beach, Hawaii, like right there, and the U.S. West Coast, that creates surf. So the jet, well consolidated, strong, reaching east. The further it has so far this year to about 145 west, right there, about maybe 143 west, and then splitting with a little bit of the jet pushing into the Pacific Northwest, making for weather up there. But California underneath, see the split flow, one there and one there. When you get that, you end up with a clockwise circulation between the split flow. That is high pressure, and high pressure gives you relatively stable air, not a lot of wind, and clear skies and no weather, which is where California has been since January 4th, I believe. So we're coming up on a month with nary a drop of rain, except maybe up into Cape Mendocino. So we'll see. We'll look into that in the future. Anyway, the jet stream. Moving on, as we get into Monday, the trough digs out more. Winds hold solid. The trough looking really good as we get Monday into Tuesday, supporting gale formation. Continuing on to the east, the trough pinches off, but some sort of another trough starts building on Wednesday night, early Thursday, the 5th of January. Somewhere in the Gulf, there you go. And then notice this, winds start building as we get into Saturday. Notice the split flow, too, on Saturday, the 7th of February. Holding high pressure over the United States, but the split point now at like 130 west, that's like 600 miles off the coast. Threatening, moving close, winds, look at this, building to 220 knots, pushing off Japan. That driven by the active phase of the MJO and westerly anomalies down here, right in this area. Strong west winds on the ocean surface blowing from on the equator. That we'll get into that, but that effectively feeds energy into the jet stream. You see it clearly delineated here. The trough north of Hawaii, as we get into Sunday and Monday, starts pinching off, but we have a much strong, look at that, the change from where we are, there we are today, which is a really good pattern. This stronger, but getting a little bit over amplified, the trough pinching off. Notice the jet getting perilously close to Central California. We'll see how that plays out when we get down and start doing surface evaluation. But all in all, a good jet stream flow. So let's go down to the ocean surface. We're looking at surface level pressure and surface level winds. Low pressure right here, 984, 980. 76, 972 millibar low here in the Gulf of Alaska. This is a previous gale, and a new gale starting to build from it. 30 to 35 knot northwest winds aimed well at Hawaii, but also the U.S. West Coast, covering a pretty good amount of area. As we get into Monday, that gale fully consolidates. We know there's a big trough setting here. 30 to 35 knot winds over a large area from the dateline almost to the central Gulf, targeting Hawaii and in close proximity to Hawaii and the U.S. West Coast. That gale continues Monday night into Tuesday, and then looks like it's starting to fade as we get into Wednesday, while a new gale, let's go back just a step here, starts building off the Kuril Islands on Tuesday, building with 45 to 50 knot winds on Wednesday, approaching the dateline. The last little remnants of the gale off of California starts fading early Thursday, while this gale takes over, still producing 35 knot winds mid-Thursday, pushing off to the east into Friday night and Saturday, and then a broader area of disturbed weather sets up off the Kuril Islands as we're into Saturday and Sunday, kind of fragmented, but supposedly it gets organized with a small area of 55-knot winds on the northern dateline, setting up more potential for swell production. Let's go look at the effect of those winds on the ocean surface. So here we go, significant wave heights for the North Pacific Ocean. We saw that before, 25.1 foot seas here, 22 or 3 foot seas. Trying to get traction. Fetch area builds as we get into Monday with seas at 25 feet, building to 26 feet, holding at 26 feet, almost pushing 27 feet Monday night. Due north of Hawaii, we're talking only maybe 500 nautical miles north of Hawaii. You see the swell front impacting the Hawaiian Islands. You see the shadowing of the islands on the southern shores of the Hawaiian Islands. Kind of cool. And that gale continues off to the east with 26-foot seas. The new gale builds behind it with 32-foot seas, building to 34 feet, continuing at 34 feet, fading some as it pushes over the dateline into Thursday. That swell you see impacting the Hawaiian Islands, the first swell impacting California. Also, let's go do one thing here. I wanted to, this fetch right here, way south, down at 30 south with 26-foot seas, totally exposed to Southern California. I think I actually did the manual calculations, like swell angle 283 degrees, something like that. So that's good news for folks that have, for the most part in Southern California, been shadowed from whatever larger swells there were this winter. Anyway, so that one fades off. Next one builds in behind, 26 to 27-foot seas, impacting the Hawaiian Islands Saturday, bound for the U.S. West Coast sometime after February 7th. And then a little bit of a break as that next gale starts winding up over the North Dateline region. Now this one much smaller, 34-foot seas. Have to keep our eyes on that. Again, this is out 180 hours. Don't trust the models more than about 4 days out, so we'll just have to see. But there is definitely hope. Then down to the South Pacific, and as teased about, a gale, look at this, on Monday evening with 31.5-foot seas, building to 34 feet and aimed pretty well off to the northeast. This is in the Hawaiian swell window and in the Southern California swell window, also for Mexico, Central America, down into South America. Now, not a huge gale. This is not some big swell-producing system, but it is hope. And the other cool thing about this is still, as we get into Tuesday morning, 31-foot seas, fading to about 27 feet, but 26 to 27-foot seas, pushing almost the whole way across the South Pacific into Thursday morning, still holding together as we get into Friday morning with 24-foot seas. So that's really good for Chile and Peru and southern Central America, we'll say, before the system finally fades out. So there is actually potential for swell. And then look at this, even another system now, this not aimed as well to the northeast, but still further north, 29-foot seas for a second. Don't know if that's believable. I'll go put more money on the first system, seeing how within 24 hours it should be organized and forming. So things looking kind of interesting for the southern hemi, considering that we're in effectively the end of January, the beginning of February. To the North Atlantic, gale building off of the Outer Banks. There's a big cold front associated with this. In Cocoa Beach, Florida, of all places, temperatures this morning at, I think it was like 8 or 9 a.m. were 25.9 degrees. For Florida, Central Florida, that is incredibly rare. So a lot of energy behind this gale. We'll see how that winds up. And of course, there's this gale off Europe, producing, as we get into Monday night, 26, 27-foot seas, almost impacting Portugal and generating surf the whole way up, or will be generating surf the whole way up into certainly France and southern UK. System off the U.S. coast builds with seas to 39 feet, 40 feet, 43 feet, generating swell targeting this whole region here. Let's see if it holds together, but no, it does not hold together, but maybe that's a good thing. That'll give it some room to unwrap. Longer period swell, maybe a little bit more organized, pushing into Europe, but really targeting the Portugal area as we get into, well, like Thursday sort of time frame. Residual seas continue in the 22-foot range. Then we get into Saturday, the 7th of February. Another gale develops with 28-foot seas lifting off to the northeast. And then here we go on Sunday, almost a week out, another rather large system building off the northeast U.S. west coast with seas at 32 feet. Again, not really targeting Florida or the mid-Atlantic or North Atlantic, but certainly generating seas, a lot of energy in the jet downstream from what's happening in the Pacific. Whatever happens in the Pacific, it all flows downstream from there, and that seems to be what is happening. Next, over to the South Atlantic. We're looking at the forecast for the next 7 days. We're looking for 25-foot seas or better. So far, nothing really showing. And there we go, 26-foot seas on Sunday, almost a week out, and all aimed off to the southeast, targeting primarily Antarctica. There we are, 180 hours out. Yeah, maybe something here, back-angled swell for South Africa, but that's a week out, probably not believable. So a pretty quiet pattern for the South Atlantic. And then finally to the Indian Ocean. Looking for anything with 25-foot seas, kind of a desperation move. I normally like 30-foot seas. 20-foot. Really, there we go. We went the whole way through the week. Tropical system off Madagascar. Just look at that, falling southeast. But other than that, really nothing. So for the first time this winter, the South Atlantic and the Indian Ocean are relatively quiet, and the focus decidedly turns to the North Pacific and the North Atlantic. Though there is a little background energy, I'll call it, forecast for the South Pacific. Interesting. The local wind forecast for California, and there's Hawaii there. There's the border between Baja and Southern California. That's Southern California. Point Conception, Monterey Bay right there. San Francisco Bay, and the Oregon-California border. Light northeast wind regime on Sunday. Yeah, I just looked at the cams, and it was, there was relatively clean conditions. In the afternoon, off the points, you get the Venturi effect and winds pick up, and there was some bump for sure. 10, 15 knot northwest winds, but not white capping or anything. And Hawaiian Island, a light south wind regime. So we get into Monday, you see a little bit of a high pressure building, ridging into the Oregon coast. That helps tighten the isobars along California, creating a gradient. Northwest winds at mostly 15 knots along California. Some flavor of south winds, 15 knots for the Hawaiian Islands, maybe pushing 20 knots as we get into the afternoon and evening. On Tuesday, the gradient relaxes in California, pretty much a light wind regime, but you just see, 5 degrees off. So we'll call that about 250 miles off of Cape Mendocino, a front in that area. Winds relative to the Hawaiian Islands, 10 knots or so. Light, probably northeast winds for California. Wednesday, again, a more or less light wind regime. Trades try to return for the Hawaiian Islands, though there is this pattern of low pressure. Thursday, indeed, a light wind regime for all of California. Some sort of a light southerly flow for the Hawaiian Islands. Friday, again, like dead air for all of California. And some sort of a south to southwesterly flow, 5 knots for the Hawaiian Islands. Saturday, still, until the jet pushes onshore in California and you don't have a particularly high pressure regime, then you end up with this just light wind flow, which is actually pretty nice. You see the high actually pushing into the Pacific Northwest. And a front over the Hawaiian Islands, north winds at nearly 20 knots. That's on Saturday. There's the front pushing right over the islands into Sunday. Sunday, northeast winds 25 knots. That's kind of a mess. And here we go. The gradient trying to set up along California, not quite making it, 10 knot winds. And there is 180 hours out. So all in all for California, more or less a light wind regime, though. A little bit of northwest winds at more exposed areas north of Point Conception. And winds definitely variable for the Hawaiian Islands, swinging between calm and south and north. So a changeable wind pattern. The rain forecast for California. Remember, split jet stream flow, the jet splitting somewhere out here with part of it heading up north. the rest of it heading south, theoretically producing high pressure over California. The blue is rain. We're looking for any rain and or snow into California. You see it just can't get past about the 135 west line. We're into Sunday, a week out. There you go. Now, I cheated and looked at the models going out 2 weeks, which I never do because they always lie and they're always wrong. But they definitely suggest that the week after Monday, tomorrow, the week after that, in the middle of the week, there is supposed to be definitely an onshore push of the jet stream, rain returning to California, snow to the Sierra. So we will keep our eyes on that. I am not betting one red dime on it, but at least there is some hope if you believe the models out that far. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley, you see it here, literally nothing, and then maybe a half an inch out. This goes out 10 days, so nothing to really get excited about yet. This goes out to the 11th, but that's right at the beginning of where supposedly the precip starts falling. So again, we'll keep our eyes on the snow level. Okay, this is the base of Palisades, Tahoe, or particularly Olympic Valley at 6,200 feet. This is the summit, top of the Palisades, and Granite Chief Peak at, let's say, 9,000 feet. Anything that was red or is red is above freezing temperatures. Anything that's gray, if there were precipitation, is sleet. And the freeze line is right here at the intersection between the gray and the white line. So you see we're up at a 12,000 foot freeze line as we get into like Tuesday, Wednesday, Thursday. Things start fading, but still the whole way out till almost the end of model. It's above freezing temperatures almost the whole way to the top of the Palisades range. Now, Mammoth goes up to 11,000 feet, so you see it has more potential for freezing, but actually these warmer temperatures is good for spring snow conditions if it doesn't get cold and stays warm for above freezing for a bit of time. Then you can get good corn snow. Mammoth, though, also has no precip forecast until out past the end of the model. Surf height forecast for the Columbia River area, right there at the intersection of Oregon and Washington. Surf height's up at 13 feet as this is late Sunday into early Monday. Let's say 12 feet early Monday. Fading as we get into Tuesday. Pumping back up into the 10 to 11 foot range on Wednesday, Thursday, Friday up to 11 to almost 12 feet, and then settling down as we get into Saturday and Sunday with surf heights in the 6 to 7 foot range with light offshore winds. In fact, the whole time, more or less, some sort of an offshore flow. Swell heights, 9 feet at 14 seconds on Monday, 8 to 9 to 13 seconds. Tuesday fades off, Wednesday back up to about 7.5 feet at 13 seconds. Friday, 7.5 feet at 14 seconds, and on into the weekend, 5.5 feet at 12 seconds or so. So not too bad. Ocean Beach, California, swell builds overnight by theoretically Monday morning, 12-foot surf. We'll see about that, but that's what is forecast. Actually, the outer buoys look pretty good. I looked. As we get into Tuesday, swell starts fading from 7 feet. Wednesday, generally small. Thursday tries to pulse up into about the 7.5-foot range. Then Friday, new swell moves in the 13-foot range, fading as we get into Saturday and Sunday. Winds, you see nothing particularly strong. Monday, northwest at 15 knots, 10 knots sort of thing. Other than that, not too bad. Let's go look at swell heights. Monday morning, 8 feet at 14 seconds, fading. Tuesday to 5 feet at 12 seconds. Wednesday, 3 feet at 11 seconds, trying to build a little. Thursday, 6.5 feet at 13 seconds. And Friday, 8.3 feet at 15 to 16 seconds, then fading from there. Down to San Diego, the exact same swell profiles. Surf heights 5 feet on Monday, fading Tuesday into Wednesday and Thursday, then back up Thursday into the 4-foot range and maybe 7 feet on Friday. I think this one's pretty well out of the west, fading as we get into the weekend. Light wind regime. Swell heights 3.6 feet at 15 seconds or so on Monday. Down from there, building to 3 at 13 on Friday. And oh, there we go. 4.5 feet at 15 to 16 seconds on early Saturday, fading on through the weekend. Wahoo! Surf heights start coming up on Monday as we get later in the day to 7 to 8 feet. Tuesday morning, theoretically 20-foot surf. You see some sort of a northwest wind here, though, at 10 knots. Fading to 15 feet on Wednesday, dropping from there into the 10-foot range Thursday, 6 feet on Friday, then back up into the 15, 18-foot range on Saturday, dropping from there. But look at this hard northeast winds at 20 knots or so, building to nearly 30 knots as we get into Sunday, turning maybe a little bit more easterly, so go find yourself a good protected corner. Swell heights building 14 feet at 14 seconds on Tuesday. Wednesday, 11 feet at 14 seconds. No shortage of swell Thursday. I mean, it just goes on. Then you get into Saturday, 12 feet at 15 seconds, dropping as we get into the weekend. A quick stop over in Central Ireland. Surf heights fading on Sunday. By Monday, 14-foot early fading. Up to, again, 13-foot range on Tuesday, fading Wednesday. Thursday, 17 feet, fading 11 to 10 feet Friday into Saturday. Then back up to 15 feet on Monday. Winds, oh, look at this, out of the east, 28 knots, pretty much steady the whole way through the week. Lots of offshore winds, lots of potential for surf. Let's go look at swell heights. 12 feet at 15 seconds early Monday, up to 9 feet at 14 seconds Tuesday. Wednesday, things settle down, but Thursday, again, 10 feet at 16 seconds. Friday, 8.5 feet at 14 seconds. Saturday, 7.5 feet at 13 seconds, and then back up to 11 at 14 at the end of the model run. Then one last stop, central Portugal. You know where. Swell surf heights up to 28 feet. This is without any swell enhancing bathymetry, just sort of just standard beach break kind of thing. 28-foot beach break on Monday, 25 feet on Tuesday, in the 20-foot range early Wednesday, dropping off and then back up to 30 feet on Thursday. You get the idea. This is winter. 20 feet on Friday. No shortage of waves. Winds, just eyeballing it here, pretty much all out of the west at 20 knots, so kind of a little bit on the junky side, I would guess. Swell heights 20 feet at 13 seconds. Tuesday, 17 feet at 14 seconds. Wednesday, 14 feet at 12 seconds. And then what do we have? Period up. Swell coming up, 19 feet at 17 seconds on Thursday. I mean, you can see the numbers for yourself. Plenty of swell. You just need some protection from the wind. All right, let's go take a look long term. We're going to examine the two major weather oscillations that affect the potential for surf and weather. Those are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to start by examining the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. The active phase is on one side of the planet, the inactive phase on the other. They rotate west to east around the equator, opposite each other as they go around the planet. The active phase is our friend. It is a low-pressure system. It takes warm, moist air at the ocean's surface, lifts it aloft. That warm, moist air eventually gets sucked into the jet stream, making the jet stream stronger, just like what we're seeing over the far west Pacific. A stronger jet consolidates the jet, makes it more efficient at digging out troughs and therefore supporting gale and storm production. The inactive phase of the MJO does the exact opposite thing. It's a high-pressure system. It creates falling air, that's dry falling air, steals energy from the jet stream. The jet stream gets weak, falls apart, can't form a trough to save its life, exactly like what we went through the entire month of December. In January, the active phase tried to get together, but now in just the past week or two, it's really started to fire up, and you can see the effects of that in the ocean and in the jet stream. But what we're looking at, The other thing, the active phase of the MJO, because it's a low pressure system, it dampens trade winds. Okay, trade winds typically blow in the Pacific on the equator from east to west, across the ocean, from Ecuador over towards New Guinea. The active phase, wherever it is, dampens trade winds. Trade winds either get weaker or reverse direction. We're going to see that very clearly here in this chart. All right, so this is literally a depiction of trade winds. This line right here is the equator. This is the West Pacific. That's New Guinea there. There's the international date line. This is the East Pacific here. This is off of Ecuador. We're just looking at the arrows. These are the 5-day average wind speeds. Just look at the arrows. Pretty strong out of the east. That's trade winds over the East Pacific. Same thing over the Central Pacific. You get to the date line, trade winds are strong, and then all of a sudden, boom, look at this. South of the date line, we're only talking 5 degrees north and south of the equator. That's what matters. And really in this box right in here, strong westerly winds blowing, not anomalies, full-on westerly winds. But it's not the actual winds that matter. It is the anomalies, the difference from normal for this time of year. So you always have trades, right? Sometimes they blow stronger, sometimes weaker. In the far East Pacific, there's no arrows, so the trade winds are dead normal. Central Pacific, just a little bit stronger out of the east than normal, making it to about the date line. There's the date line, but then here you go. Here are your strong westerly anomalies, all mainly south of the equator. North of the equator, everything's normal. So some sort of active phase of the MJO and westerly anomalies, or whatever you want to call it. This is what is in turn feeding the jet stream aloft. We saw that, the jet stream looking very strong. Let's go see what's been happening the past 5 days. Maybe this will drive it home even a little bit more. Here's the 5-day 850 millibar zonal wind anomalies. So this isn't the ocean surface. This is up 800 at the 850 millibar level, which is roughly 4,700 feet. Let's get ourselves oriented. South America, Central America, Australia, New Guinea, 0 is the equator. The date line 180 west. So you can see right here the oranges, and it's 5 degrees north and south of the equator across the Pacific. That's all we're looking at. Strong westerly winds on January 26 from the entrance to the Pacific at about 125 east, the whole way over the date line and beyond. That continued on the 27th, 28th, 29th, and the 30th, though weakening a little bit. Notice they're starting to fall more south of the equator. So this looks like a full-on westerly wind event. Now, why does that matter? Well, for one, it feeds energy to the jet stream, but two, what it does is takes warm, moist. The ocean temperatures are always warm here over the maritime continent. Those westerly anomalies start grabbing that warm water, start spilling it over into the Pacific, and warm water starts building in the West Pacific, but it also has momentum because the winds are blowing on it. Creates a ball of warm water that travels from west to east the whole way across the Pacific, not on the ocean surface, but under the ocean surface. It's called a Kelvin wave. And we have 2 of those in motion. We're going to get into that in a minute, but just keep in mind, westerly anomalies not only feed the jet stream, they create Kelvin waves. And when warm water starts moving east and erupting off of Ecuador here in the Nino 1.2 region, then all of a sudden water temperatures start warming off here. And that is the hallmark of El Nino, a redistribution of heat from in the ocean from the West Pacific to the East Pacific. And so this looks like a good pattern for starting to set that up. Let's keep going. Another component of the MJO, the Madden-Julian Oscillation, is when you have the active phase of the MJO, it takes warm, moist air and lifts it aloft. Well, eventually that warm, moist air hits the upper atmosphere. Things are much cooler up there at the jet stream level. That warm, moist air condenses and starts forming clouds, more clouds than normals. The blue here is, this is what they call outgoing long wave radiation, sunlight reflecting off the ocean surface. If you have more sunlight reflecting off the ocean surface, like the reds, like here, here's Australia, New Guinea, the equator right here, this is the Indian Ocean, there's Africa, India, and maritime continent. You get more sunlight reflectivity if you have downward falling dry air, the inactive phase of the MJO. So the reds is effectively the inactive phase of the MJO. But the blues, here is the date line, again, far west Pacific, active phase of the MJO. This is, as of today, 5 days from now, according to the statistic model, it's holding, but then 10 days out, about a week and a half from now, see the inactive phase starting to move into the West Pacific, active phase fading, and then 2 weeks from now, inactive phase in control. That doesn't look good. That is from the statistic model. The dynamic model, at least a little bit rosier. It says active phase, weak active phase, and then 10 days from now, well, pretty much nothing and dead neutral 2 weeks from now. I'll take that any day of the week. What is the forecast for 850 millibars zonal winds? Okay, this is past performance. This is the forecast, but this is for the whole planet. So the date line's right in the middle of the chart. Okay, far west Pacific starts at 125 east. Here's where we have been through the whole month of January, west anomalies making it almost to the date line. Here is the peak of our, I'll call this a westerly wind burst that lasted into January 27th. But even today on February 1st, you saw the westerly anomalies still holding. Easterly anomalies east of the date line, that doesn't matter. It's really from the date line and west of there what matters. Now, last week, I got very excited about a supposed westerly wind burst, another one that was supposed to set up right here, look like this, only stronger. Now, this model, the GFS model, goes, well, maybe not. Maybe a little bit of westerly winds. That was only like a week out last week, and here we go. Now we're like 4 days out, and it's just a burst of westerly winds, and you see it all kind of collapsing. So this sort of mirrors what the statistic model is saying, though this is also the dynamic model. So a backup of the fuel going into the Jetstream as we get, this is actually 2 weeks there in 5-day increments, believe it or not. So 2 weeks out. Then there is the CFS model, a dynamic model optimized for looking way out into the future. This is past performance, so it goes back November, December, January, and then a forecast that goes out 4 weeks. So let's sort of review. This has the MJO actually laid on it. And right off the bat, here is the date line right up the middle. Far West Pacific starts 125 east. That's all that matters. So you can see in November, here was our active phase of the MJO, westerly anomalies reaching into the West Pacific the first time in like a year or two. Probably 2, that was enough to create a Kelvin wave and push warm water off to the east. That is the Kelvin wave that when we get into the subsurface discussion in a minute, you're going to see is poised to erupt off of Ecuador. Inactive phase followed. January tried to get it together, and then December was dominated by this inactive phase, easterly anomalies. Then as soon as we got to January 3rd, active phase set it up. Here was westerly anomalies. Kelvin wave number 2 was generated during this westerly wind event. Now here we are today, or actually 1 day ago. The CFS model, at least at the moment, is suggesting as we get to February 14th, another westerly wind burst is forecast. The same one that the GFS model last week was hinting at, but now says no. The CFS model continues to say yes. Not a huge event, not as pronounced as this one, but still solid westerly winds, certainly capable of feeding the jet stream and supporting perhaps another Kelvin wave. And then finally, the CFS model going out not 1 month, but 3 months. The forecast is up here. What has happened is down here, and the date line runs right up the middle. The blues are easterly anomalies, the yellows and reds westerly anomalies. You can see clearly a change between what has been on the date line with easterly anomalies and what is coming, which is steady westerly anomalies. Now let's put this in again. Here was the November westerly wind burst. Not particularly impressive, but it created a Kelvin wave. Here is the December inactive phase of the MJO with easterly winds. Here is the January westerly wind burst that created a Kelvin wave. Here is the February pulse, the CFS model. Now note, this model is run a day later than the last one we just saw, still predicting that westerly wind burst stronger than the one in January. I'll believe it when I see it. It's only a week out, and then now we're into fantasy land up here, but just look at what is forecast coming. Pretty impressive. Let's overlay the MJO. Okay, we're in the middle of the active phase of the MJO, right at the peak of it today. Okay, you see though that as we get into February 9th, the weakest of weak inactive phase sets up, but still it doesn't stop the westerly wind machine from doing its thing. Another active phase, another weak inactive phase, and notice at the end of these inactive phases and the beginning of a building active phase, you get the westerly wind thing. Same thing happens here, not as strong. Then here you go up here, and this is all located on the date line when we're in April. This sort of hints that maybe there could be, this might be a late winter, but when it finally wakes up, it could be pretty impressive. Now, again, do I believe a model going out 3 months? Of course I don't, but it is teasing. Let's overlay the low pass filter here. All right, why is all this happening? Well, we have the La Nina indicator, this dotted, the high pressure bias. It had two contours from October the whole way into January. That first contour disappeared. And notice already as of this date, the high pressure bias is starting to move away from the date line and into the East Pacific. And the low pressure bias, which has been locked over the maritime continent, it's not really moving much, but in the next week or so, it's going to start theoretically making this push off to the east and continuing, and now with supposedly 1, 2, 3 contours as we begin to get into the beginning of April. No wonder you see why there's strong westerly anomalies. Now, am I going to put money on this? Absolutely not. The other thing to take note here, as westerly anomalies start moving into the Pacific, over in the maritime continent and the Indian Ocean, easterly anomalies start building and building and building. Look at that, a high pressure bias sets up. This is the classic El Nino flip. You go from La Nina, dominated by high pressure over the date line and lower pressure over the maritime continent, to up here, low pressure over the date line and high pressure building over the maritime continent. A total pressure regime switch. This suggests, perhaps, at a minimum, we're moving into a much more favorable pattern to support storm and gale development in the Pacific and perhaps rainfall into California. And if that's at the conservative end, at a more liberal end, perhaps the development of El Nino. The westerly wind bursts, 1, 2, 3, and the creation of Kelvin waves help to reinforce that, because when warm water moves off to the east, it eventually pulls up off of Ecuador, creates evaporation, that rising air, same sort of deal, lowers pressure off of Ecuador, and then helps feed energy pushing into California and across the North Pacific. All right, so I've talked about Kelvin waves, the movement of warm water east on the equator, moving from the West Pacific to the East Pacific, driven by westerly wind bursts in the active phase of the MJO. So here is data from the TAO buoy array, a series of buoys strung across the equator from the East Pacific to the West Pacific. These are the actual anchor lines on those buoys. The X's are sensors down the anchor lines. They give us temperature data of what's going on subsurface. And in between, you use a model to fill the gap. So we have the 30-degree isotherm. It hadn't moved any since last week. This 30-degree centigrade, that's warm water. 29-degree isotherm, about the same where it was. 28-degree isotherm, about the same where it was. The 24-degree isotherm, though, suggests that there is this shelf of building warm water off of Ecuador to the whole way to a point south of California. This would be 25 meters deep, so 75 feet deep. That wasn't here before, and that pool appears to be growing. Why is that? Well, this is the average temperatures, but let's go look at the anomalies, the difference from normal for this time of year. Whoa, look at this. All of a sudden, we now have a pool of 4 degree above normal water temperatures in the far West Pacific. Where's the date line? The date line is right here. Encroaching across the date line, a finger now of 1 degree anomalies. There's another 1 degree, another 1 degree isotherm there. This is the first Kelvin wave pushing up into Ecuador somewhere in that area, with Kelvin wave number 2 building and pushing right behind it, probably somewhere right around in here. And if this next westerly wind burst occurs, it's going to take more warm water from the maritime continent, dump it into the ocean, and set it in motion as well. This is the same data, but enhanced by satellite data. You can clearly see an entire river of warm water moving from the far west Pacific starts about 125 east, under the date line, the whole way up, and just now poised to erupt at about 100 west to, let's say, 120 west, somewhere here in the far west Pacific. Let's go look at the satellite data. Sea level anomalies. These are not temperatures. This is the height of the ocean. That is, you strip out all the waves, all the wind waves, all the tides, and this is a sphere of the ocean higher or lower than normal. Why does that matter? Well, if you have warm water at depth, warm water expands. When it expands, it creates a bump on the ocean surface. Cold water at depth, down, that little river we were looking at running under the equator, cold water contracts. And when it contracts, you'll end up with a divot, a divot, like a dig out on the ocean surface. And literally, we're talking 5-10 centimeters, like literally that much. But the satellite is super sensitive. The tech is amazing. All right, so let's get ourselves oriented. That's what this chart is about, though. Here's the equator. Here's the date line. There's New Guinea. There's Ecuador right there, that little squibble right there. That's the Galapagos Islands, Central America. You get the idea. Now, this entire summer has been dominated by this entire area here with -10, -15 centimeter anomalies, inferring cold water at depth. But now, this updated just yesterday, positive anomalies, not much, 0 to +5. Also building here, this entire area from the date line on the equator. And again, I said it was only 5 degrees north and south of the equator. The whole way to Ecuador, and all of a sudden you see building anomalies along Ecuador as well, suggesting that warm water is pushing into this area. It hasn't really done its thing yet, but a Kelvin wave is in flight, poised to erupt at the ocean surface somewhere around here. Let's go do one more subsurface look. Upper ocean heat anomalies over time. West Pacific here, East Pacific here. Here's last year's Modoki La Nina. Last summer in April, May, June. A little bit of, the La Nina pattern faded, but then it reappeared here in July. We had 1, 2, 3 pushes of the inactive phase of the MJ, and you see the active phase trying to make some headway, but just not doing anything. And then all of a sudden, in November, we got a real active phase of the MJO. It made a push. You see it right here with setting warm water in motion. And then here was our next one in January. We see that pushing even further into the Pacific, and you see the sum total of all that warm water now at 195 west at depth, right where the other chart said, what was it, between 80 and 100, I think, or 110, something like that. That's where the Kelvin waves should be erupting. So let's go look at surface temperatures. See surface temperature anomalies. South America, Central America, New Guinea, the equator right there. Dateline right there. Blues are colder than normal temperatures. What the heck? Where is the warm water? Now remember, it is subsurface. It is down 150 meters, 450 feet, and it's traveling from through these little channels here, falling into the Pacific, going the whole way underneath all this, and is poised to erupt somewhere right around here. It hasn't quite done it yet, but at some point we're going to see this stuff lighting up, probably in the reds, and it could be any day now, or it might be a week or two away. So warmer than normal temperatures clearly are evident along here. I think that's more a reduction of trade winds than anything, but we still have the remnants of La Nina, not particularly strong, certainly not getting any stronger. They've actually shrunk in coverage. They did fill all this area, and they extended almost over to 165 west 2 weeks ago, getting smaller in coverage, but still not gone yet. But this is the place to watch. The sea surface temperature trend for the past 7 days. South America here, Ecuador right there, the equator right here, dateline right here. You see generalized warming. There is a little tiny pocket of warming. Maybe that's the first little finger, maybe a little bit there, but that's kind of a maybe and a guess. Also, a little bit concerning, I see some upwelling all of a sudden here. This wasn't here before, right along Peru, but I suspect this is going to be short-lived. This is probably local high pressure pushing south winds up the coast, creating upwelling. But there is still a broad area of warming off the coast here. Embedded pockets. I mean, I don't know that anything is fully warming. It seems like it's more holding neutral. Now, Nino, the early monitor region, Nino 1.2 is right here. The official El Nino monitoring region from 120 west out to 170 west, 5 degrees north and south of the equator. Looking here, neither warming nor cooling, probably holding steady. An alternate technique for measuring sea surface temperature anomalies using the global mean still shows a big La Nina cool pool in effect here. So what we're seeing is in the West Pacific with the Kelvin waves, there is a trend occurring. It's not at the surface yet. We're looking at what is potentially happening. We know there are 2 Kelvin waves underwater, not visible yet. But again, remember, it takes warm water on the ocean surface, creating evaporation to change the air mass above that to then start affecting the weather patterns in the Pacific. So all these little clues that we are looking at subsurface are a hint of what is to come, but they have not been realized yet on the ocean surface. Here's a raw sea surface temperature trend for the Nino 1.2 region, right there by the Galapagos in Ecuador. Today, we'll pull this down a little bit. There you go. Today's value, 176 thousandths of a degree below normal. So basically, neutral is considered half a degree above to half a degree below. So we've been neutral for 2.5 weeks. Okay, so we're on the very leading edge of this. Now, the official El Nino monitoring region is the Nino 3.4 index. That region, again, from south of California out to about the dateline. Temperatures there still clearly in La Nina, 920 thousandths of a degree below normal. Neutral, half a degree above to half a degree below. Weak La Nina, half a degree below to 1 degree below. And that is exactly where we are today. But we know a Kelvin wave is coming. We know it's going to erupt. We know there's multiples of them. That at some point should start pushing these numbers up. We will see it first, though, over here in Nino 1.2, right off of Ecuador. So what does the atmosphere think is going on? We look at the difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Central Pacific, Darwin over in the Maritime Continent. When pressure is lower in Tahiti, the index goes negative. Well, today it's 26.51. That's pretty high. But we had a good run of negative here in January. You see that right in there. And again, most of these westerly wind bursts, active phase of the MJO stuff, has been in the far West Pacific. It hasn't even made it to Tahiti because Tahiti's at like 140 west, and all the activity's been mostly west of the dateline at 180 west. So this region still dominated by cooler than normal water temperatures, which makes higher pressure. So today, anyway, we are in looks like the inactive phase of the MJO over in the East Pacific. And where were we a month ago? 9.62. A lot of variability here depending on 30-day average. Good way to sort of just average out what's happening today. Plus 0.8, 0.7. Still positive. Where were we a month ago? 2.46. So active phase moving to inactive, kind of undefined. The 90-day average, 6.68. Where were we a month ago? 8.02. So all this still indicative of some flavor of weak La Nina. Let's look at the data on a graph. Here we go, 30-day running average SOI graphed out. Downward spikes are the active phase, upward spikes are the inactive phase. This was last year's La Nina. Actually, no, I'm sorry. Last year's La Nina was here. 1, 2, 3 spikes. This was a inactive phase. This is what shut things down in December. Then here was our, December. This was our November push active phase of the MJO, inactive phase, another active phase in January. Now we're kind of just hovering around here somewhere. Neutral, +7 to -7. We're still, according to this, but remember, this is heavily influenced by the location of Tahiti, which is in the central Pacific, and most of all the active phases of the MJO and the westerly wind bursts have been confined to somewhere around the date line and not making it any further west. So what is the sea surface temperature forecast from the CFS version 2 model for the official El Nino monitoring region, the Nino 3.4 region? Where have we been? Temperatures hovering around neutral into July. Then we got a bit of a 0.5 degree below to 1 degree below is La Nina. Here was our weakest of weak La Ninas in October, November, and January. As of right now, this is January 15th. We are 0.5 degree above to 0.5 degree below. Officially, we're in neutral territory according to this index. And as we get into March, so that's middle of January, middle of February would be right about there. End of February, beginning of March, we officially cross over into full neutral territory. And you don't really want to let your eye wander out to here, but okay, I will. Temperatures 1.6 degrees, if not 1.65 degrees above neutral out in October. Again, we're looking like, 6 months from now. They were up to 1.75 last week. Now, this is the uncorrected. The corrected version, there it says corrected, says, well, only 1.25 degrees. But if you're at plus 1.25 in October, that's pretty warm. Do I believe any of this? No, but it definitely suggests the trend is to let's just get ourselves over the next 2 months and into neutral territory. That would be a huge step forward. All right, so let's wrap this thing up. Where are we at? Well, series of gales are forecast over the dateline, pushing into the Gulf of Alaska, sinking further south than anything so far this winter. That sets up, of course, swell for Hawaii and Northern California, north of Point Conception. But fortunately for Southern California, yes, at least one of these is clearly in the swell window, and it seems likely that some sort of swell will result for breaks south of Point Conception, and they will not be shadowed. Looking a little bit further out, we have westerly winds over the far west Pacific, potentially, depending on which model you look at, the development of a third Kelvin wave. That would be great news, pumping more warm water. It takes 3 months for that to make it across the Pacific. So if that happens, let's say in the next 2 weeks, 3 months from there, we're looking at mid-February to March, April, not till May till you see that warm water hit off of Ecuador. Then we're way past the winter time frame. Won't do anything for us surf-wise. The best thing from all this is another westerly wind burst, feeding energy to the Jetstream, feeding our storm track. And from there on, if this happens, it seems like some sort of rebalance that would push us over the tipping point to get us out of La Nina and perhaps into some flavor of at least neutral, if not a warming pattern in the Pacific. Hooray, we need it. We've been suffering for a couple of years now. Precipitation-wise, yes, I can look at the models and go, well, maybe as we get into mid-February, finally this high-pressure pattern will break. The jet stream will start pushing into California and we'll get precip. But there are no guarantees there, and I am not going to try to fool you into believing that that is the case. But I will be an optimist and say, I think we're due. At some point, these patterns always break down, and hopefully in the next 2 weeks it will. All right, that's our video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Little bit of time, the subscription numbers are coming up. I do appreciate you subscribing. If you have a comment or question, I know we've gone way down the weeds here. Write it up down below. I would be happy to help clarify anything that I maybe misspoke about. And finally, if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We will do it again next week, same time, same channel. Go get some waves, and let's hope for more.